It is possible to make a loop installation in asphalt or concrete driveways. This involves embedding a wire loop into the pavement to create an inductive loop detector. Here is how it's typically done. The necessary materials are conduit, wire loop, concrete or asphalt, and sealant. The process begins with cutting a groove in the pavement where the loop will be placed. The groove should be deep enough to accommodate the loop and conduit. Next, insert the wire loop into the groove. The loop should be positioned in the area where vehicles will pass over it. Secure the loop in place with sealant or other adhesive. Then, cover the loop with a protective layer of asphalt or concrete. Install conduit by running the connecting wires from the loop to the detection equipment. The conduit provides protection and allows for future maintenance. Finally, connect the wires to the inductive loop detector, which will sense the presence or movement of vehicles over the loop. There are several benefits of loop installations in driveways. Firstly, automated gate control. Loops can be used to automate gate opening and closing when vehicles approach or leave the driveway. Secondly, traffic counting. Loops can count the number of vehicles entering and exiting the property. Thirdly, security monitoring. Loops can detect unauthorized vehicle access and trigger alarms or notifications. Fourthly, convenience and efficiency. Loop installations can enhance convenience and reduce the need for manual gate operation or traffic monitoring. There are also several considerations. Firstly, pavement type. The type of pavement, asphalt or concrete, and its thickness will affect the depth of the groove and the installation process. Secondly, vehicle weight. The loop should be designed to withstand the weight of vehicles that will pass over it. Thirdly, loop size and placement. The size and placement of the loop will determine its sensitivity and effectiveness. Fourthly, equipment compatibility. The loop installation must be compatible with the specific inductive loop detector used. The inductive loop consists of one or more turns of insulated wire embedded in a saw cut into the pavement. The inductance of this loop is sensed by an electronic detector. The presence of a vehicle over the loop decreases its inductance, which is sensed by the detector. This change in inductance closes the detector's output relay, which sends a signal to the gate operator or other control device. Proper loop design and installation are essential for reliable operation. The loop wire should be continuous, without splices from the loop to the detector location. The wire should be installed in a saw cut at least 1 and 1/2 inches deep. The saw cut should be thoroughly cleaned and dried before the wire is installed. After the wire is installed, the saw cut should be filled with a flexible sealant. The sealant should be flush with the pavement surface. The loop size and shape should be chosen to match the vehicle being detected. A typical loop for detecting passenger cars is 6 feet wide and 6 feet long. The loop should be centered in the lane of traffic. The number of turns of wire in the loop should be chosen to match the detector being used. A typical loop has 3 to 5 turns of wire. The loop wire should be connected to the detector using shielded cable. The shield should be grounded at the detector location. The detector should be located in a weatherproof enclosure. The detector should be powered from a reliable power source. A detector should be properly adjusted to ensure reliable operation. Inductive loops are a reliable and cost-effective way to detect vehicles. They are used in a variety of applications, including traffic signals, parking garages, and gate operators. The basic principle behind an inductive loop is electromagnetism. An alternating current is passed through the wire loop, creating a magnetic field. When a metallic object, such as a car, enters this magnetic field, it changes the inductance of the loop. This change is detected by the loop detector, which then sends a signal to the connected device, like a gate or traffic light. There are several factors that influence the performance of an inductive loop. These include the size and shape of the loop, the number of turns of wire, the depth of the saw cut, the type of sealant used, and the sensitivity of the loop detector. The size and shape of the loop should be tailored to the specific application. For example, a larger loop may be needed to detect larger vehicles, or a differently shaped loop may be necessary for detecting vehicles in a specific area. The number of turns of wire affects the sensitivity of the loop. More turns generally increase sensitivity, but also increase the loop's inductance, which can affect its performance. The depth of the saw cut is important for protecting the loop wire from damage. A deeper cut provides better protection, but also requires more sealant to fill. The type of sealant used is crucial for preventing water and debris from entering the saw cut, which can corrode the wire and degrade the loop's performance. The sensitivity of the loop detector should be adjusted to ensure that it accurately detects vehicles without being triggered by other metal objects or electrical interference. There are several different types of inductive loop detectors available, each with its own features and capabilities. Some detectors are designed for simple presence detection, while others can measure vehicle speed, length, and direction. Some detectors also have advanced features such as automatic tuning and fault detection. When installing an inductive loop, it is important to follow the manufacturer's instructions carefully. This will help to ensure that the loop is installed correctly and that it performs reliably. It is also important to use high-quality materials and tools. This will help to extend the life of the loop and reduce the risk of failure. Regular maintenance is also important for ensuring the long-term performance of an inductive loop. This includes inspecting the loop for damage, cleaning the saw cut, and resealing if necessary. With proper installation and maintenance, an inductive loop can provide years of reliable service. In addition to the factors mentioned earlier, the environment in which the loop is installed can also affect its performance. For example, loops installed in areas with heavy traffic or harsh weather conditions may require more frequent maintenance. It is also important to consider the potential for electromagnetic interference from nearby sources such as power lines or radio transmitters. This interference can cause false detections or reduce the sensitivity of the loop. There are several techniques that can be used to mitigate electromagnetic interference. These include using shielded cable, grounding the loop properly, and installing filters on the loop detector. It is also important to keep the loop away from sources of interference as much as possible. Inductive loops are a versatile and reliable technology that can be used in a wide range of applications. By understanding the principles behind their operation and following proper installation and maintenance procedures, you can ensure that your inductive loops provide years of trouble-free service. The placement of the loop within the driveway is crucial for its effectiveness. Consider the typical path vehicles take when entering or exiting the driveway. The loop should be positioned so that vehicles consistently pass over it. This might involve placing the loop in the center of the driveway or strategically positioning it to capture vehicles approaching from different angles. The shape of the loop can also be tailored to the driveway's geometry. While rectangular loops are common, other shapes, such as circular or diamond-shaped loops, may be more appropriate for certain driveway layouts. Experimentation and careful observation of vehicle traffic patterns can help determine the optimal loop shape and placement. When securing the loop in the groove, ensure that the sealant or adhesive is applied evenly and thoroughly. This will prevent the loop from shifting or becoming dislodged over time. It is also important to use a sealant or adhesive that is compatible with the pavement material and the loop wire insulation. A poor choice of sealant can lead to corrosion or degradation of the loop wire, resulting in premature failure. The depth of the groove is also critical for the loop's long-term performance. A groove that is too shallow may not provide adequate protection for the loop wire, while a groove that is too deep can weaken the pavement structure. The ideal groove depth will depend on the type of pavement, the size of the loop wire, and the expected traffic load. Consider consulting with a paving contractor or an experienced loop installer to determine the appropriate groove depth for your specific situation. When connecting the loop wires to the detector, ensure that the connections are secure and properly insulated. Loose or corroded connections can cause intermittent failures or complete loss of signal. Use high-quality connectors and terminals, and protect them from moisture and corrosion. Proper grounding is also essential for preventing electrical noise and interference. Connect the loop shield to a reliable ground point, such as a grounding rod or a metal water pipe. When selecting an inductive loop detector, consider its features and capabilities. Some detectors offer advanced features such as automatic sensitivity adjustment, frequency selection, and diagnostic capabilities. These features can simplify installation and maintenance and improve the overall performance of the loop system. Also, consider the detector's power requirements and its compatibility with the available power source. Choose a detector that is energy efficient and that meets the specific needs of your application. In addition to vehicle detection, inductive loops can also be used for other applications such as pedestrian detection and bicycle detection. By adjusting the loop size, shape, and sensitivity, you can tailor the loop system to detect a variety of objects and events. For example, a smaller, more sensitive loop can be used to detect bicycles or pedestrians crossing a driveway. This can be useful for enhancing safety and security in residential or commercial settings. Inductive loops can also be integrated with other security systems such as cameras and alarms. When a vehicle or pedestrian is detected, the loop can trigger a camera to record video or send an alarm notification to a security monitoring center. This can provide an extra layer of protection against unauthorized access or suspicious activity. The cost of installing an inductive loop system can vary depending on the size of the loop, the type of detector, and the complexity of the installation. However, in general, inductive loop systems are a relatively cost-effective solution for vehicle detection and access control. The long-term benefits of increased security, convenience, and efficiency can often outweigh the initial investment. When planning an inductive loop installation, it is important to consider all of the relevant factors and to choose the right components and techniques. By following these guidelines, you can ensure that your inductive loop system provides years of reliable and trouble-free service. Remember to check local regulations and codes before starting any work. Permits may be required for certain types of installations, especially in public right-of-ways. Also, be aware of any underground utilities that may be present in the area. Contact your local utility companies to locate and mark any buried lines before digging. Safety should always be a top priority when working with electrical equipment and tools. Wear appropriate personal protective equipment such as safety glasses, gloves, and hearing protection. Follow all safety guidelines and procedures, and never work alone. If you are not comfortable performing the installation yourself, consider hiring a qualified electrician or loop installer. A professional installer can ensure that the loop system is installed correctly and safely, and that it meets all applicable codes and regulations. They can also provide valuable advice and support, and help you troubleshoot any problems that may arise. Inductive loops are a valuable tool for automating and enhancing access control systems. They offer a reliable and cost-effective way to detect vehicles and pedestrians, and can be integrated with other security systems to provide comprehensive protection. By understanding the principles behind their operation and following proper installation and maintenance procedures, you can ensure that your inductive loop system provides years of trouble-free service. The key to a successful loop installation lies in careful planning, attention to detail, and the use of high-quality materials and techniques. By taking the time to do it right, you can enjoy the many benefits that inductive loops have to offer.